Hi, I'm Dave Burley. I'm an instructor here at the University of Maryland in the physics department, and this is Newton's Cradle. So I want to ask you, if I take and pull one of these spheres, now all this is just a number of 5 suspended spheres. If I pull the one here that's furthest to the left up and release it, what's going to happen? Now, after that, I want you, before I just talk about it, I'd also like you to think what would happen if instead of lifting 1, I decide to lift 2. Is there a pattern that can be generated? So let's try it out. So most of you have probably seen this before, this toy before, and it is kind of straightforward. Lift one ball up, let it come down and collide with the rest of the system, one ball comes out in the other way. That's a measure of looking at a rule that we call the conservation of linear momentum. This ball is going to collide with this second ball. And of course, the second ball has nowhere to go, so it transfers that momentum that it got from the first ball into the third ball, which also has nowhere to go, and it transfers that momentum into the fourth ball, which has nowhere to go because there's another ball in the way, and that means the fifth ball kind of moves out. So it's a matter of looking at a collision, and in all circumstances when we talk about collisions, linear momentum will be conserved. This is a special kind of collision because it's referred to as an elastic collision, where we could say that the kinetic energy of the ball that's leaving is really, really going to be close to the kinetic energy of the ball that's coming out. So an interesting way in which you can think about that is, of course, when we lift it, how fast this ball comes out and how high it goes is dependent upon how high I release the first ball from. Now, I also asked you another question. What if I release 2 balls instead of 1? Now, if I'm careful and we go through this, what will happen is the number of balls and the conservation of momentum dictates that if I drop 2 in, 2 have to come out. And I can keep playing with this and say, okay, let's try 3 balls. 3 go out. So we could play with this a lot, and this is going to be true regardless of how we kind of set up our configurations. I can have 1 ball on either side, or 1 ball comes back out. Or we can even go crazy and say I'm going to have 3 to the left and 2 to the right. And they transfer back and forth, all because of that conservation of momentum under the circumstance of an elastic collision.